Hello. So this is a Python program to find a data, that is to search a data by using binary search algorithm. So in binary search, the data should be in sorted order, either in descending or ascending. Then we can perform binary search. So we need to input some key value. Then the program search whether that value is present in that sorted list or not. And it also retrieves the position of that data in that list. So here we use some list equal to. So this is the initialization of list. Then we need to input the limit, how many numbers, whether it is 5 number or 7 number or 10 number, like that. Then we need to input those numbers in ascending order by using for loop. Then this is the code to store, to append that data into a list. So we need to input that data. Then we need to append, add. That is, we need to store that data to the list. So this is by using for loop. For now in range, limit means this limit, how many numbers. And we need to store those numbers in this list. Then we can print that list to see. Okay. Then after that, we need to input the search data in the search item. So it's stored in the search item variable. Found is set to flag because we not yet find that variable. Yeah. So found is set to false. Found is a Boolean variable. It can be either true or false. Search value is also a Boolean variable. It can be either false or true. First is a variable set to initialize to 0. Last means it shows the length, how many data in that list. That length minus 1. Because in Python for loop or in Python for loop or in list, in Python array, we need to start from 0th index. So if there are 5 numbers in that list, then the last index is 4, not 5, because we start from 0. That's why 0, 1, 2, 3, 4. So we need to subtract 1 and we need to store that into last variable. Len means it's an inbuilt function which retrieves the number of data in a list. Then we need to find the middle number, middle data. So what is the code for that? We need to use some while loop. While not found. Not found means what found is at first it is true, false, yeah, at first false. So not false means it's true. While true and not search, not search value actually search fail is actually false. So not search fail means not false, that is true. So true and true, both are true. Then it enters. So here actually found should be false and search fail also should be false. Then only it enters because we use not, the opposite one. Yeah, not, that's why. So if both are true, because we use and in between, so for true and true is only true, it enters. So we need to find the middle data, middle list, middle index. So first plus last, this integer division means if it is 5, then 5 double slash 2 means it's not 2.5, here it is only 2. So we need to use double slash. Okay, there is integer division. Then we need to check with that list middle. This is the middle number, middle element. This is the middle index, and if you use we write list of middle, it is the middle data in that list. If it is equal to, this is comparison operator. If it is equal to search item, this item, then found is set to true. Otherwise, if it is not equal, then we need to check whether the first, okay, the first is greater than or equal to last. Okay, so what is first and last here? First is the 0th beginning, and last means the end value, end index. So this is first is the beginning index, and last is the end index. So if the first value If first value is greater than second last, means index exceeds or is equal to, means it's finish, the searching finished. So if it is like that, then we need to we need not want to search again because it's already finished. That's the meaning. So we can set search failed to true because not data in that list. That's the meaning. And if otherwise, then the next condition is if list of middle item is greater than our search item. What is the meaning of that? If middle item is greater than, so here the data are in ascending order. Okay, so if middle item is greater than search item, means what is the meaning of this? Search item is less than middle item. So our data is on the left side of the list. So we need to change the last index to middle -1. Else means if it's opposite. Middle item is if it is less than search item. So because search item is greater than middle item, means that search item is in the right side of the list. So we can ignore the left side. Understand? We can ignore the left side. So this process continues. So we can ignore some right side or left side based upon the comparison, and we can make the list smaller and smaller. So we can find, the system can find very easily. That's why that is the feature of efficiency of binary list. We can make the list smaller and smaller. That is called divide and conquer method. So if it is else means if the search item is greater than the middle item, then we can that item is in the right side of the list. So we can ignore the left side. So first index we can change to middle +1. So this process continues until what? If found becomes true. Found becomes true when? If list of middle is equal to search item, found set to true. So it comes here. What happened? Not true means false. False means what? The system need to exit from the while loop. Second condition is what? If search fail equal to true. If the searching finished and no item in the list, that's the next condition. So search fail should be true here. It's set to true now. So search fail not true means it's also false. So it can exit either found is set to true or search fail equal to the program can exit from this while loop. Understand? Then what happened? At the end, after when the program exits this while loop, it checks whether found equal to true. If found is set to true, what's the meaning of that? That search item is present. The search is successful. So it can print the message item found in position, and it can display the message which position is that. So why we add middle +1? Because I said before, it's by default it starts from 0, so we need to add 1. That's why. So if it is in list, if it is in third position, actually it is in the fourth position because 0, 1, 2, 3. It starts from 0. So third position means actually it is fourth position. So that's why we need to add mid +1. Okay. Then if it is found is not true, then it prints item not found. So I'm going to run this program. Enter limit. So I'm going to input 7 numbers. Okay. Then enter numbers in ascending order. 4, 7, 8, 9, 10, 45, 67, 78. So these are the numbers in my list. Okay. Then I need to find a number. For example, 45. Yeah, item found in position 5. Yes, 5 because 1, 2, this is 2, 3, 4, and 5. Fine. Okay. Then we can run again. The limit 7, 2, 4, 5, 6, 8, 90. 1 minute. Okay. 90, 9, okay. So I need to find one number that is 7. Okay. 7 is not on the list, so item not found. Okay. Thank you.